Continuing in this section on problem solving with algebra, we're going to look at a couple more examples. The first one says, consider each of the following subtraction problems in which the digits are reversed. So we have 32 minus 23, 42 minus 24, 71 minus 17, 51 minus 15, and 76 minus 67. So it says, what do all of the answers of these computations have in common? So subtracting 32 minus 23, that's 9. Oops, there we go. 42 minus 24 is 18. If you subtract, 71 minus 17 is 54. 51 minus 15 is 36. And then 76 minus 67 is 9. So what do these answers have in common? Well, if you look at them, all of the answers are multiples of 9. So 9 is just 9 times 1, right? 18 is 9 times 2, 54, 9 times 6, 36, 9 times 4, and then again, 9 times 1 for 9. Part B says, using algebra, we're now going to generalize this. Show that if A and B are digits, then the difference of the numbers represented by AB and BA is always divisible by 9. So if we have the number that we typically write as AB, technically, dealing with place values, we've got the A in the tens place, the B in the ones place. So we could rewrite this as 10A plus technically 1B, but we don't need to write that 1. So again, the A is in the tens place, the B is in the ones place. Using that exact same logic, when we're looking at BA, this time the B is in the tens place, the A is in the ones place. You could rewrite this as 10B plus, again, 1A, though we don't need to write the 1. Now, it really doesn't matter, but I'm going to assume here that A is greater than B. So I'm going to assume that AB is a larger number than BA, okay? So when I subtract AB minus BA, it's going to be positive. So AB minus BA is equal to 10A plus B minus 10B plus A. Just writing them in expanded form. So that's 10A plus B minus 10B minus A, distributing the negative throughout that second parenthesis. So now combining like terms, 10A minus 1A is going to be 9A. B minus 10B is going to be negative 9B. So you could rewrite this as 9 times A minus B, just factoring out the 9. Since the answer is always going to be 9 times the difference between A and B, it is always going to be divisible by 9. And there is a proof right there. You've just done a proof. You've shown that this is always going to be true. So the next one on this page, we're looking at a rectangle. It says a rectangle is 3 times as long as it is wide. So let me stop there and I'm going to draw a picture. So it's 3 times as long as it is wide. So I'm going to let W represent the width. So my length is going to be 3W, 3 times as long as it is wide. It has the same perimeter as a square whose area is 4 square feet larger than that of the rectangle. What are the dimensions of both the rectangle and the square? Okay, we got a lot going on here. So here's my square. And my square, I'm going to say, has side S. So all 4 of them are going to be S. And I'll go ahead and fill in these others. So we're going to end up here with two equations and two variables. So it talks about the perimeter and the area of these. So let me go ahead and write out the perimeter and the area for each of these. For the rectangle, the perimeter, if you add these four together, it's W plus 3W plus W plus 3W, so that's a total of 8W. The area is length times width, so it's going to be 3W times W, or 3W squared. Now, moving on to the square, its perimeter is just going to be 4S, and its area, S times S, or S squared. Now, it says, the rectangle has the same perimeter as the square. So that means, and I'll write it over here to the side, the perimeters are the same. That means that 8W equals 4S. In other words, if I divide both sides by 4, 2W equals S. Okay, so we know this now. And it says the area of the rectangle is 4 square feet larger, or sorry, let me go back again. The square has an area 4 square feet larger than that of the rectangle. So the area of the square is 4 square feet larger than the area of the rectangle. So S squared is equal to 3W squared plus 4. Now, we know that S is equal to 2W. Oops. Sorry, y'all. I had S on my brain and I wrote an S instead of a 3 here. Let's try that again. There we go. We know that S is equal to 2W. So I'm going to replace that. Our S with 2W. So 2W quantity squared. 2 times 2 is 4. W squared is W squared. So I get 4W squared equals 3W squared plus 4. We subtract 3W squared from both sides. I'm running out of space here, but we'll make it work. We get 4 minus 3 is 1W squared, or just W squared. So W squared is 4. So to find W, we just take the square root of both sides. And technically, when we take the square root of 4, we can get either a positive or a negative 2. But in this case, we're talking about the width of a rectangle. We don't have a negative width. That just doesn't make sense in real life. So W is going to be the positive 2. Now, if W is positive 2, we can go ahead and find the dimensions of the rectangle and the square. The rectangle, it's W by 3W, so that means it's a 2 by 6 rectangle. For the square, we know that the side of the square is 2W, so it's a 4 by 4 square. And there's our dimensions.